You're watching the MPiec Web UI video tutorial series. In this video, let's use the Remote I/O HMI interface to operate the training demo. Hi, I'm Matt Pelletier. Here's a quick preview. We'll jog each motor, set the zero position, and execute relative and absolute moves. This simple HMI also shows how it can be easier to replace a component of the system in the field without relying as much on the web UI. I'll go through controller replacement, amplifier replacement, and motor replacement. So I invite you to follow along as we go through this in more detail. To follow along in this tutorial, you'll need connection to one of our MP3300 IEC and Sigma 7 demo units. If you would like remote access to one of these demos, please request by email to training@yaskawa.com. You can see how this works in the remote connection e-learning video. In the previous video, you installed the archive to the controller, sent the parameters to the drives, and reset the absolute encoders. At this point, the remote I/O shows that there are no alarms, although there is a zero set required indication for the Z-axis, and that's because the program is detecting that the servo position has never been set. So let's move each motor to the zero position and then click Set Zero. I'll start with the X-axis, servo on, and then enter a jog speed. 20 might be good. And then click jog. Sometimes you gotta wait to see which direction is appropriate. And I'll just jog until I see zero up here. It's pretty much arbitrary for this demo. And I'll go over to the Y-axis and also set the speed. Let's just do 20 again. And jog. A little more. Okay. And now we'll go to the Z-axis. I'll turn the servo on for the Z-axis. Set the speed. And jog. That looks about right. And you can see down below the actual position feedback is not zero, but if we go through and click the Set Zero button, it sets the actual position to 0 for each of the axes. Now you might see the Z-axis kind of fluctuate between 0 and 360, and that's because 0 and 360 for this rotary axis is the same position. Now let's do a relative move, meaning relative to the current location, and we'll set a distance of, how about 90 degrees, or 90 millimeters as the case may be. And with the servo enabled, this is on the X-axis, we'll move relative. And it moves to 90 degrees. On the Y-axis, I could move to, how about negative 180? And I'll go a little faster on this one. How about 100? And hit move relative. And it went backwards to position 180. And finally for the Z-axis, I'll put in a negative 90 for this one too. Negative 90. Enter. And hit move relative. Let's speed that up a little bit here. How about 100? I'll do that again here, move relative. So I can keep clicking this move relative, and it will just keep moving relative to its current position. Now compare that to move absolute. We can put in the absolute position. Could tell it to go back to 0, which is the data that's already in here, and tell it to move to position 0. I think I'll do that for each of these axes. Have them move back to 0. Back to 0, and back to 0. The over travel inputs, pot and not, are wired to the Z-axis, And disconnecting one of these inputs is indicated by P or N on the display, and it prevents the motor from moving in the indicated direction. Here I've got not disconnected, so I can jog positive but not negative. And the opposite is true. If I disconnect pot, leave not connected, I can now not jog positive and I can jog negative. And of course, if they're both disconnected, then it says P and N, and you won't be able to jog any direction. These inputs are usually implemented as proximity sensors at the end of the mechanism to prevent the load from moving too far. Of course, here the load is just a wheel and it really can't move too far. So just keep both of these connected unless you want to test what happens when the motor hits one of them. And be aware of what P or N on the display of any of these amplifiers means, and realize that it's not an alarm. It's just an input that stops the motor in one direction or the other. So this is just a real basic, fundamental type of servo operation that we have implemented here on this demo. As far as the rest of these buttons down here, you can see we have the ability to write the parameters from the archive into the servos. We have the ability to reset the absolute encoder, and we already did set 0. We also have the ability to reboot the controller and servos. These are all operations that we've done within the web UI. They can also be done here through this remote I/O HMI interface. So let's start with the controller. Let's turn the servos off here. So what would you have to do if the controller had to be replaced? Let's look at the quick reference guide. Section 1.D says we need to set up the controller, then load the project archive, reboot the controller, and we'll have to then zero set the machine again. Let's simulate that in the web UI by deleting the two pieces of data that the controller currently is using to run. That is, as you know, the archive. So we'll go in and delete the archive. And the other part is the SRAM. Let's initialize the SRAM. And so now this controller is at factory default, except for the Ethernet configuration. So let's go ahead and reboot it. And you can reboot that here through the controller interface. It's going through the reboot cycle. And now we've got a controller that's basically got nothing on it. It's as if you pulled out an old one and put in a new one. So let's log off and log back in as if this is a brand new controller. Sign in. And what do we need to do? Just like in the last video, we would go to the archive and send an archive. Let's add archive. Can use that same archive that we've supplied in the training. Open and send and install. Now that that's finished, you reboot the controller. You've got to keep track of what's going on here. The controller's not using this archive yet, so you're not going to be able to use the remote I/O interface yet. We will have to reboot using the web UI. Okay, here we've recovered from the second reboot. And if you take a look here, there is an alarm. Under the alarms, it says that the PLC had to perform a cold start because that means that the retained variables were cleared out. We talk more about warm start and cold start in the IEC Basics video series. And so this is why we see that zero set is required again. Whatever variable it was that remembered if the 0 point had been set for this encoder, that variable has been reset. And the position is now invalid, so we'll do zero set required. And we're back in action. Turn the servos back on and set your speeds again. Try 20 and jog positive, jog negative, or you can move to absolute 0. Next, what about replacing one of these amplifiers? Let's say we're going to replace the Z-axis amplifier controlling this motor. The quick reference guide, section 1.E, describes how to replace that drive or servo pack. First, you install it, set the Mechatrolink address in the rotary switch, and then we can log into the web UI or use our built-in functionality in order to send drive parameters before finally rebooting the system again. If a drive is replaced, it's going to have the factory default parameter set. So let's go to the Setup menu under Drive Parameters and simulate that factory default condition on the Z-axis by writing the factory default parameters. Now this amplifier has the factory default parameter set. Okay, now if this amplifier were replaced, of course the control power would be disconnected. And let's reconnect the control power. Now you see we have an alarm. It's an alarm because this drive does not have the correct parameters. It's been reset to factory default. As an aside, when you do replace an amplifier, you want to check the Mechatrolink node address, which is under this cover. First we'll reboot the system so that we can reconnect these drives to the controller. You can see that they're complaining about being disconnected when I turned the control power off. So we're connected again and reading in this alarm, ACC0. You may remember ACC0 is an absolute encoder related alarm, but in this case it's because we don't have the correct parameters set in the amplifier. Let's write the parameters to that amplifier. And you guessed it, reboot again. And after the reboot, the alarm is gone because we have the correct parameters in the drive. Once again, we can turn on the servo and jog. Notice the jog speed is remembered because that's a retained variable in the controller. We didn't do anything to the controller this time. Move back to 0. And now the last simulation is the motor replacement. Think about it for a minute. If you replace a motor, you've got to remove the cables from the encoder and you're putting on a new motor. So let's simulate that by turning off the power to this amplifier and then disconnecting the cable to this motor. That's the encoder cable that you see on the other motor being disconnected and connected again. And we'll apply control power now. And you see the amplifier has this alarm, A.810. As before, when we remove power to this amplifier, that interrupts the Mechatrolink 3 network communication. And the easiest way to restore that is just to reboot the controller. So we'll reboot that controller. And now the controller is back online with the drives, and it's reading that alarm, A.810. Quick reference guide, section 1.F, does point out that after you install the replacement motor, you'll have to clear alarm A.810 and ACC0 before you reboot and calibrate the 0 position again. We can reset the alarm with absolute encoder reset. Reboot is required. One more time. And this controller knows, after the reboot now, that there is no alarm, but it also knows that anytime you reset the absolute encoder, the absolute position is no longer valid and a 0 set is required. So as before, you would move the motor to the 0 point, and because it's not at 0, and click 0 set required. That's how you go through and replace the motor. You can see there's a lot of controller reboots involved when you are replacing any of the components, and of course write the parameters if you ever replace the amplifier, and reset the absolute encoder if you ever replace the motor. I now invite you to play around with this demo as much as you want. Simulate the replacement of each component and go through the recovery process using the web UI or the remote I/O until you're confident. In the certification test, we'll ask you to load an archive just like this and use the functions of this interface. Beyond the web UI, I'm guessing some of you would be curious to see the source code for this demo project. The project is included in the class materials download, and you can open it with MotionWorks IEC version 3, as I've done here. Here I have the maintenance POU with worksheets for write PN, absolute encoder reset, and reboot. You can see them in debug mode, and it's even possible to monitor the code as it operates with the remote I/O interface. For example, I'll do an absolute encoder reset, and it turned that one red. If this is new to you, please see our self-guided training courses called IEC Basics and PLC Open Basics, which will teach you how to use this software. Thank you for watching this video, and remember yaskawa.com/IEC for more information on the MPiec product line.